Start with the basics. What exactly is a prime number? A prime number is an integer greater than one that has only two factors, one in itself. For example, numbers like 2, 3, 5, 7, and 11 are all prime. Interestingly, 2 is the smallest and the only even prime number. On the other hand, composite numbers have more than two factors. Now, prime factorization is the process of expressing a composite number as a product of prime numbers only. There are two main methods to do this: the factor tree method, where you keep splitting the number into branches until all ends are prime, and the repeated division method, where you divide by prime numbers until you reach 1. For example, 24 can be broken down into 2 times 2 times 2 times 3 using either method. This foundation is essential for understanding GCF and LCM. Next, let's talk about the greatest common factor, or GCF. The GCF of two or more numbers is the largest number that divides all of them without leaving a remainder. To find the GCF, you first factorize each number into its prime factors. Then you select only the common factors with the smallest exponent and multiply them together. For instance, to find the GCF of 18 and 24, you factorize 18 as 2 times 3 times 3 and 24 as 2 times 2 times 2 times 3. The common prime factors are 2 and 3, and you take the smallest power for each. So GCF equals 2 times 3 equals 6. This method ensures you find the highest number that fits evenly into both numbers. Now let's move on to the least common multiple, or LCM. The LCM is the smallest non-zero number that is a multiple of all the given numbers. To calculate the LCM, you factorize each number, then take all factors, both common and unique, with the largest exponent for each, and multiply them together. For example, for 18 and 24, you use the highest powers, 23 and 32, so LCM equals 8 times 9 equals 72. This approach ensures that the LCM is divisible by each original number. Understanding the difference between GCF and LCM is crucial. GCF uses only common factors with the smallest exponents, while LCM uses all factors with the largest exponents. See how these concepts apply in real life. Imagine a teacher wants to distribute 36 pens and 48 notebooks equally among the largest possible number of students with nothing left over. To solve this, you find the GCF of 36 and 48, which is 12. So the maximum number of students is 12, and each student gets 3 pens and 4 notebooks. For advanced learners, consider this challenge. If two numbers have a GCF of 12 and an LCM of 144 and their sum is 84, what are the numbers? Using the rules product equals GCF times LCM, and expressing each as multiples of 12, you can solve for the exact values. These exercises help solidify your understanding and show how math is used in everyday problem solving.